Transhumanism is a loose conglomeration of philosophical ideas fueled by scientific advancements in the fields of engineering, computer science, and medicine, which have led to the creation of human enhancement technologies. In the not-so-distant future, the vast accumulation of research and technology in these respective fields of science may result in the largest and most pivotal revolution ever to occur in the history of mankind. These scientific improvements could potentially give life to a new class of human being and restructure the whole of human society, sparking conflict between two distinct forms of life. Transhumanism is being proposed as a potential solution to a multitude of existential threats, including climate change, environmental pollution, physical disabilities, and even human mortality. Among the many developments in human enhancement technology, a few recent biomechatronic inventions have allowed us to attach robotic prosthetics onto amputees.
So many people around the world are living with some loss of upper limb function, and in many cases, their brain activity is still sound. So if we can record that brain activity and then decode it to try and figure out what they're trying to do, we can then make a robotic prosthetic execute that function for them. I think that'll give them greater independence in their life. I'm Sam Parker. I'm studying a Bachelor of Electrical Engineering at the University of Newcastle. When you are trying to move your hand, your brain generates an electrical signal, and that electrical signal travels to your scalp, where we can measure it using electroencephalography, or EEG. We can digitize that signal and then send it to a computer chip for further processing. I use a machine learning approach to decide whether you're trying to open your hand or close your hand, and once I've decided what you're trying to do, I will then make the arm do that motion. Working with specialized hardware, I needed to design custom PCBs, custom circuit boards in order to use them properly. And that was a bit of a design challenge. You need to go through the documentation and figure out how I'm going to implement it. And then also trying to determine the signal against the noise. It's a very, very small signal we're trying to read. And so trying to determine what the person's trying to do when we read their signals, it was really quite complicated. One of the goals of my project was to make a very simple brain-computer interface, and that's really what I have achieved in the project. So it was a great experience and really allowed me to get my feet wet in brain-computer interfaces, because this is where I want to be heading in future years with my research. Later this year, I'm heading to Brown University in the United States, where I'll be doing my PhD in biomedical engineering, focusing on brain-computer interfaces. Brown University is one of the top schools for brain-computer interfaces in the world, so it's really been a dream come true. Studying my undergraduate degree at the University of Newcastle, I feel like has really prepared me well for my PhD at Brown. We were able to cover a broad range of fundamentals, but then through selecting my electives and my directed courses, I could really specialize on my area of interest. And what I'm hoping my research will do will be to create more advanced prosthetics so I can help people who have lost upper limb function get a second grasp on life and gain greater independence.
These technologies will serve as a great blessing to those who may be suffering from the hardships of living without limbs. Such improvements to our standards of living should be praised and embraced. However, just as we acknowledge the potential for good, we also cannot neglect to address concerns about this technology being abused. Should we perhaps consider how the technology used to produce these robotic limbs may be altered to function as weapons?
Human enhancement technologies are being researched into ways in which we can change the very nature of us as humans, and this has important impacts on soldiers and the ways in which we fight wars. As examples of technologies that are being researched at the moment, exoskeletons and prosthetics. These involve adding mechanical means or new limbs to amputees and others to increase their strength and endurance, such as the Tactical Assault Light Operator suit. We have cognitive enhancements. These involve pharmaceuticals, brain stimulation, electronic brain stimulation, and other means to reduce the need for sleep and increase the capacity to operate under stress. There's also some interest in changing nutrition and eating. Some of the more extreme examples of this are changing someone's stomach so that they can digest cellulose, which means that soldiers can eat grass. In terms of enhancement and ethics, there's been a lot of ethical interest in enhancement for a while. Some of the general concerns that people have around enhancement are changing our very nature as humans. If we enhance ourselves such that we're no longer the same as we are now, are we still human? This has an important potential impact in terms of warfare and military practice, because if our enemies see us as no longer human, then they might be treating us quite differently. For instance, if you see someone in an exoskeleton coming to attack you, you might not think of them as human, and you might not afford them the normal concern that one gives to a soldier in war. Another set of concerns come from informed consent, where we worry about whether the subject of research or the receiver of enhancement can effectively give consent to this. This is particularly interesting or relevant in the military context because militaries have hierarchical command structures and soldiers are told to follow commands quite often without the need to question those commands. Another more important or more relevant set of concerns around enhancement in the military context build off the notion of enhancing someone's cognition and then their capacity to follow the laws of armed conflict. Because if you change the way someone thinks, this can also change the way in which they follow, or how they follow the laws of armed conflict, and this is of course quite important. If we look at the history of enhancement, it goes back a long way. The use of nutrition and training to increase the capacity to win a war. More recently, we can see the use of amphetamines during World War II and after that to give soldiers the capacity to fight, days on end, for pilots to fly long flights. The final thing to say is this is not necessarily a new concern. We've got worries about the way in which soldiers are treated generally, humanitarian concerns about soldiers and civilians. What these new enhancement technologies do is shine a new light on these existing concerns and also force us to think about the ways in which we use new technologies and the research conducted around them.
U.S. Special Ops is working on a new robotic suit. Joining us now with details is Chris Osborne of Scout Warrior. Chris, is this really like an Iron Man suit?
Hello, Amy. Very similar. A lot of us grew up with the Iron Man action figures, the comic books, and then more recently we saw the movies. And indeed, Special Operations Command is working on something that is similar in a number of respects. It's called the TALOS, or Tactical Light Operator Suit. It began a couple years ago. The one you see here is by Revision Military. They are just one of a number of vendors involved. Lots of industry teams and academics looking at this issue. Some of the potential technologies include advanced armor composites, command and control computers, sensors, integrating night vision, power generators, enhanced mobility exoskeletons, so you can carry a heavier load, some kind of powered skeleton aligned along the contours of the body to increase strength without restricting mobility. Also, part of this is the military plans to use a technology developed by the Massachusetts Institute of Technology, MIT, called a next-generation liquid armor. It basically transforms from a liquid to a solid in milliseconds when a magnetic field or electrical current is applied. Now, Special Operations Command told Scout Warrior they plan to have some initial prototypes of this by 2018.
Another area of concern in the transhumanist revolution is the science of gene editing.
Gene editing. You may have heard it linked to talk of GMOs, genetic enhancements, or even designer babies. But what is gene editing? And how does gene editing work to let us modify plants, animals, or possibly people? To answer these questions, let's take a closer look at DNA, RNA, and one of the best tools for editing genes, CRISPR. So what is DNA? Well, all of your genes are made of DNA. It is the instruction manual that tells your body how to develop and how to work. All of the DNA in a cell is called the cell's genome. A copy of the genome is found in most of your cells in a part called the nucleus. It's your DNA that controls many of your traits, like your eye color or how many toes you have. To control those traits and to keep your body working, the information in DNA needs to reach other parts of the cell. But DNA can't leave the nucleus. So how can those instructions be used? There's another molecule that helps, called RNA. RNA is similar to DNA, but it can send those DNA instructions out of the nucleus. Working as a sort of copy of the instructions, it can move to other parts of the cell. This lets your cells use DNA instructions to create proteins that keep your body working. Now, as you grow, your cells divide. Each of these new cells needs a copy of your DNA instructions, but the copying system isn't perfect. Sometimes mistakes are introduced during copying. How do these mistakes happen? If we look at DNA at a microscopic level, it has 4 different types of bases. Billions of these bases are all connected in very long pairs of strings. When cells divide, these paired strings need to be copied so a new set of DNA can be included in both cells. While copying these long strings of DNA, it isn't unusual for a cell to make a mistake. DNA can also be hurt or broken by things like exposure to too much sunlight or to certain chemicals. The good news is that our bodies have molecules that look for and help fix those mistakes. There are special proteins called enzymes that are always looking for mistakes or for damaged DNA. If they find it, they cut out that tiny part of the string of DNA. Then they replace it with a new, correct piece. Another important feature of DNA is that it has 2 strings that aren't the same, but that are a matching set. So if you have one string, you would know what the other string is supposed to look like. If only one string of DNA has a mistake, the other can be used to let the enzymes know what needs to be added. But if both strings have problems, both need to be replaced. A situation like this can be used to introduce new DNA. How did scientists figure this all out? For the last century or so, people have studied how DNA works. We learned that it passes on genetic information, and we know what it looks like. We also learned which genes are involved in certain diseases and which genes cause specific traits. There are even kits you can get to gather a sample of your own DNA to send in to be tested. You can see your risks of disease or learn about your ancestors. Once scientists knew the basics of how genes worked, the next step was to figure out how to change or modify specific genes. You may not know it, but humans have been modifying the genes of other organisms for thousands of years. But in the past, we've done this by picking which animals or plants to breed, by exposing eggs or seeds to radiation, or by adding genes to DNA at random. In the late 1900s, scientists discovered ways to carefully insert specific genes in exact locations in DNA. But this was very difficult and expensive to do until recently. A newer method called CRISPR has made gene editing much faster and cheaper. CRISPR has 2 main parts, a piece of RNA called guide RNA or gRNA, and an enzyme that cuts DNA. The gRNA can be made to find and connect to a specific place on a strand of DNA. Once the gRNA has lined up the CRISPR system on the DNA, the enzyme cuts the DNA. The enzyme used most often as a part of CRISPR is called Cas9. Once the DNA has been cut, the cell's own response of trying to fix it takes over. The cell will start to repair the cut. It uses either a remaining strand of DNA, a recent copy made from the DNA if it is still in the cell, or it will just rejoin cut ends of DNA. But if scientists introduce a strand of DNA that they've designed, it could be used as the instructions to repair the damage. This means a new gene that wasn't there before could be made and added to the DNA. In this way, CRISPR-Cas9 has been used to fix genes, remove genes, and add genes. It can also make genes stop working temporarily, which we call gene silencing, or stop working altogether, which we call a gene knockout. There are many ways the CRISPR system can be used. It could help avoid or cure disease, repair DNA damage, or even make existing genes work better. But taken further, those tools could also be used to make designer babies or to make microscopic weapons, like drug-resistant bacteria. CRISPR technology is here to stay, and for good reason, but there is an ongoing debate about what should be off-limits for gene editing. In the comic Spider-Man, after Peter Parker's genes are modified, giving him superpowers, his uncle tells him something that rings true in real life now. With great power comes great responsibility.
Could this technology be abused by governments who seek to control the intelligence and behaviors of the people they govern? Where exactly do we draw the line? Do human beings have the right to change their own DNA? Is it reasonable to think ourselves wiser than the intelligence which gave rise to our existence? With this kind of technology, that is the question that must be asked. If the language of DNA is an extension of the intelligence which resulted in our inception, then is it morally acceptable for the conscious faculties of intellect to manipulate the source of its creation? Is it sensible or even sane to want to change one's body on such a fundamental level so as to transform the very conditions which gave rise to the uniqueness of our conscious experience of the world? Various philosophies and religions teach that it is somehow the desire of the conscious mind to detach itself from the physical body. Perhaps such a belief is what led to the ritualistic consumption of various psychedelic drugs. Since hallucinogenic substances can affect the mind in such a way that enables us to explore the more ethereal spectrums of our existence, it may be said that psychedelics allow us to experience what it would be like to exist outside of our bodies. Whether or not psychedelics actually remove the conscious mind from the physical body has yet to be proven, and is indeed another question entirely. According to these philosophers and religious teachers, the entirety of human existential history may be summarized in the evolutionary pursuit of the liberation of consciousness. From the gradual sophistication of scientific knowledge to the progression of philosophical thought and morality, and the transformation of the natural world. Inventions, innovations, institutions, violent revolutions, modes of production, systems of government, and art. All of these things being the observable manifestation of an effort by the conscious mind to liberate itself from all forms of restraint. From the restraint of despotic tyranny, the restraint of hunger and thirst, the restraint of ignorance, and the restraint of every conceivable force which operates to suppress the ambition of total conscious liberation. Will we abandon our natural bodies in favor of a biomechatronic upgrade? Could such a transition even really be considered an upgrade? Our ever-increasing reliance upon electricity to power the machines and devices which drive the course of our daily lives has raised a cause for concern about the catastrophic consequences of potential cyber attacks and solar magnetic disturbances. According to experts, within a year of a national power outage, around 90% of the population will have died. The degree of chaos precipitated by a national power outage would cut off access to water, food, transportation, and create an explosion of social unrest, the likes of which the world has never seen. For this reason, we have witnessed a peak in the consumption of information pertaining to lifestyles which promote self-sufficiency, including educational books and videos that teach about living off-grid, homesteading, building gardens in the city, doomsday prepping, and urban disaster survival. If one thing is certain, it is that the contradictions brought about by the existential threats we face as a technologically advanced society are causing a great chasm in the ideological trajectory of humanity. On one side, we have people that believe technology will save humanity from annihilation, and on the other hand, we have people that believe a return to a more orthodox style of living is the only escape from destruction. Exactly how these two schools of thought begin to take shape in the coming society will be a sight to behold. We can expect to see the formation of various political and religious factions, each struggling to preserve their respective ways of life. At this moment, Elon Musk is proposing the merger of human beings with artificial intelligence by way of surgically implanted interface mechanisms as a solution to the phenomenon of machines replacing humans in the workforce.
But we do want a close coupling between collective human intelligence and digital intelligence. Neuralink is trying to help in that regard by creating an interface between, a high bandwidth interface between AI and human brain. We're already a cyborg in the sense that your phone and your computer are kind of an extension of you.
Just low bandwidth input output.
Exactly, it's just low bandwidth, particularly output. I mean, 2 thumbs basically.
So how do we solve that problem?
The bandwidth thing?
It's a bandwidth issue. I mean, we've all succumbed to it now. We're all cyborgs. We're just low efficiency cyborgs. So how do we make it better?
I think we've got to build an interface. Like we didn't evolve to have a communications jack. or some. So there's got to be essentially vast numbers of tiny electrodes that are able to read write from your brain. Of course, security is pretty important in this situation, to say the least.
I was going to say, I'm not coming with. I'm keeping my brain air-gapped.
Yeah. Well, I think a lot of people will choose to do that. But it's a bit like Ian Banks' neural lace. Mm-hmm. But in the case of neural lace, it's sort of that's there from when you're born, or it's more of a backup. Sorry?
It's a backup.
Yeah, kind of a backup. This would be there's a digital extension of you that is an AI. The AI extension of you, a tertiary layer of intelligence. So you've got your limbic system, your cortex, and a tertiary layer, which is the digital AI extension of you. And that high bandwidth connection is what achieves a tight symbiosis. I think that's the best outcome. I hope so. If anybody's got better ideas, I'd love to hear it.
If mere machines can take over the human workforce, then we can expect for biomechatronically enhanced human beings to present an even greater challenge. Without a doubt, in the near future, unmodified human beings will have to compete with modified humans for jobs. The nature of this dynamic could require us to redefine the term human being and perhaps give life to a new kind of racism. Imagine a future society in which people are organized by a hierarchical system of human augmentation. What would that mean for the human experience on this planet? How will that affect the psychology of a species which prides itself on being the pinnacle of intelligent life? Will there be a mass exodus from modern civilization by a people who, by reason of human integrity, choose to part from the radical path of transhumanism? We cannot ignore the fact that technology has a way of enslaving us to our own natural vices by freeing us from the very work which contributes meaning to our existence. What is to become of the human spirit in an artificial world? Will AI dim the blaze of humanity? Or will it amplify the radiance of humanity's true light? The technological advancement of the modern world has not come without its handicaps. Social media, for example, while revolutionary in its ability to connect people, has produced somewhat of the opposite effect by encouraging addictive and antisocial behavior, particularly in children. Could it be that the explosion of mental illness, particularly anxiety and depression, have been set off by the psychological effects of social media? It's not at all a stretch to suppose that social media may be a primary cause of all kinds of destructive behaviors in children and young adults. If such a level of ruin is the price we must pay for supposed advancements in communication, then what does that mean for the future, and how will transhumanism affect the psychology of the youth? Despite what some may think, becoming a cyborg won't answer all of our questions or solve all of the existential problems we encounter in life. Technology will do as it always has, and that is make life just a bit more bearable for us. But this benefit of technology exists only insofar as we do not enslave ourselves to the things we've built with our hands. Technology must serve as a tool and nothing more. With all that we have seen in pop culture from the Matrix trilogy to cyborg video game protagonists, it is easy to get carried away by extremist notions concerning the idea of becoming more than human, a kind of human 2.0. But we cannot forget where we've come from. One of the greatest challenges that we will face as a human species in the coming transhumanist revolution is remembering who we are and knowing our place in the world. As the human mind and body undergo a process of transformation, people will feel as though technology has given them the power to redefine themselves in any manner they see fit. This will, without a doubt, cause a lot of confusion. Therefore, we must remember that being a human is about love, because love is what compels us to accept the mortality of our existence. When we understand that our lives are lived in service to one another, we are less likely to fear death because we know that we are a part of something much greater than ourselves. Knowing our purpose will allow us to choose the right path when the time comes.